Hi and welcome to another video on additional mathematics, continuing the simultaneous equation chapter. Now you are going to learn how to solve simultaneous equations, but you will focus first on two linear equation over here. So for two simultaneous linear equation, what you have to do is to use the following two methods commonly known. Okay, the first method is called elimination method and the second one is called substitution method. Now, for the step to success for this topic, you are going to use elimination method. Involves eliminating a chosen unknown by making the coefficients of the unknowns the same. However, for substitution method, you are going to change the subject first. Okay, if you chose an equation, you change the subject, and then what you do with it is to replace it into another equation. So let's begin by checking what is simultaneous equation. Essentially, a simultaneous equations for many cases in additional maths involve two unknowns. For example, if you are given x plus y equals to 3. Now, if you think about the solution, you will find out that there are many solutions for the equations above, yeah? Then we can kind of guess, for example, for the values of x and y, maybe you can say that to get 3, you can actually have x equal to 0 and y equals to 3, or there may be 1 for x and then 2 is for y, or maybe you can have 2 for x and then 1 for y, and so on. Now, however, if you introduce another equation, x minus y equals to 1, you should only have one solution. That is true for both of the equations above. So for example here, now we already had this list of numbers. Okay, this list of numbers here, 0 and 3, 1, x equals to 1, y equals to 2, and then x equals to 2, y equals to 1. So which one of this will fulfill both equation x plus y equals to 3 and then x minus y equals to 1? I want you to pause and think. Yep, you already know it. It's going to be x equals to 2 and y equals to 1. That will satisfy and solve both of the equation at the same time. So that's why they are called simultaneous equation, because you are supposed to find a solution that can solve both equations simultaneously. Alright, let's move to the methods that we can use. There are two methods that can be used to solve simultaneous equations. They are called elimination method, and the second one, we call it the substitution method. Now let's have a look at elimination method first. Now, as you have seen in the steps to success, elimination method involves eliminate an unknown by making the coefficients the same. So when you have a look at this example 1, you must have noticed that in this two equation, 5x plus 2y equals to 9, and then the second equation is 3x plus 2y equals to 5, you must notice that there are two with the same sign as the coefficient of y. So what we do is we can eliminate them by subtraction. So what it means by subtraction over here is that whatever you are going to subtract in the left hand side of the equation number 1 will subtract whatever is on the left hand side in equation number 2. So these two are subtracted from each other. So you will also do the same thing on the numbers on the right hand side over here. You are going to subtract them also. So what we will write down, we're going to be looking like this. So in the first equation, the left hand side expression is 5x plus 2y. And for the left hand side of the second equation is 3x plus 2y. So what happens is that you are going to subtract them from each other. So for the second equation, the second equation left hand side, you must give a bracket, and equals to, on the right hand side is going to be 9 minus 5. So all you need to do is just try to solve this equation. Now here, if you rearrange the term, and then you also here you also apply negative to 3x plus 2y, the 5x, the like term together with it is going to be minus 3x. And as for the positive 2y, the like term that is going to be together next to it will be minus 2y. So here you must have noticed that 2y minus 2y equals to 0. So that means y is eliminated over here, leaving you with only x as your unknown. On the left hand side, it's done. Now for the right hand side, it's going to be 4, and 5x minus 3x is 2x equals to 4. Now this one, 2x equals to 4. In order to solve it, we have to divide both sides by 2. So therefore, x equals to 2. Now for simultaneous equation, it is not sufficient if you only find x, the value of x only. You must also solve for y. So here, what are you going to do is you are going to use or substitute x equal to 2 into one of the equation above, so that you can find the value of y. So here, let's say substitute x equal to 2 into the first equation, copy it down back, which is 5x plus 2y equals to 9. So here, x will be substituted. Okay, so 5x means 5 times 2, or you can use bracket 2 plus 2y equals to 9. So this one is easy to solve. 10 plus 2y equals to 9, and you have to move 10 to the right hand side, and you will have 2y equals to 9 minus 10 is going to be negative 1, which means y equals to negative half. If you divide 2y divided by 2 and negative 1 divided by 2, you can leave it as a fraction of negative half. So that's for the first example. Alright, now moving on to the next page, let's have a look at example number 2. Now here, if you notice, you don't have any unknown with the same coefficient number yet. So here, for example, 5x and 2x, and then 2y and negative y equals to 25, and also 1 in the second equation. So here, a tips for you to do is to check which one of the unknown is easy to eliminate. So here, the suggestion is to multiply the second equation by 2. So here, let's write multiplication of 2 into the whole equation, and you don't have to do anything with the first equation. So here, let's copy down the first equation with no change. 5x plus 2y equals to 25, and for the second equation, 2x minus y equals to 1. You have to multiply all of them by 2, so you will have 4x, and then minus y times 2 is going to be minus 2y equals to 1 times 2 is going to be 2. Now, behold, this is what you have seen. You have done here. You can notice that you have 2 with different signs as the coefficient of y in both equations. So what do? Is we eliminate them by addition. So I want to show you what I also write down. Another way to write it down is by writing this down, and the way that you can remember what you are going to use after you have the same coefficient, it's either addition or subtraction, is by remembering a mnemonic here, STOP. So S means same sign, that means you are taking away, so you are subtracting, and OP means O opposite, and P means plus. So here, if you have the same sign of the same coefficient, that means you are going to subtract both equations. But if you have the opposite sign with the same number of coefficient, you are going to plus or add. So here we are picking add or selecting add. So here you can look at this vertically. So here it's easier to see. 5x plus 4x equals to 9x, and 2y plus negative 2y will give you 0. So here this y unknown is eliminated, equals to 25 plus 2 is going to be 27. So here you proceed with solving for x. So 9x equals to 27. So you divide both sides by 9. Therefore x equals to 3. Now you are going to find y for the next step, so you have to proceed with substitute x equals to 3 into one of the equation above. So say here I will use the first equation, which is 5x plus 2y equals to 25. So here x will be replaced by putting in 3. So here 5x means 5 plus 3 plus 2y equals to 25. So the rest of them is going to be simple. 15 plus 2y equals to 25, and 15 is moved to the other side. So it's going to be on the left hand side is 2y equals to 25 minus 15. You will have 10. 10, so which means the final answer for y is going to be therefore 5. Right, so that's for the elimination method for the first two examples. And here, this is sort of like I will give all of my students as do it yourself. So here, in this situation, you have to choose the first unknown that you have to or you want to eliminate. Here in this case you can actually choose whether you want to eliminate x or whether you want to eliminate y. So the tips that I can give you here is to use LCM on the coefficient of the unknown that you want to eliminate. So here, if you want to eliminate one of the unknown, and after you are using LCM, then you can multiply both equations with a suitable number to make sure that the coefficients of the chosen variables are the same. So here, for example, if we choose say y to be eliminated first, so what you can do is to find the LCM of 3 and 2. So LCM of 3 and 2 is 6. So here your objective is to make the unknown of y, the coefficient of y equals 6. So here for the first equation, focusing on making 3y into 6y, which means you have to multiply this whole equation by 2. And as for the second equation, to make 2y into 6y, you have to multiply 2y into 3. Alright, so here you have to change both equations. So 5x plus 3y equals to 13. You have to multiply them by 2, so you have 10x plus 3y times 2 equals to 6y equals 13 times 2 is 26. And as for the second equation, you will have 3x plus 2y equals to 8 times 3. So you will have 6x plus 6y. Sorry, apology for this one. 3 times 3 equals to 9x plus 6y equals to 8 times 3 is 24. Now, I would like you to try yourself to solve for both of the unknown. Pause the video and you will check the answer later. Alright, now you can see here, this is the full solution, and please check whether you have x equals to 2 as your final answer and y equals to 1. So here, just to briefly explain the working, once you have 6y as the same coefficient on both equations, so here you have to check the sign. So the sign here are the same, so what you're going to do is you subtracted both equation on the left hand side and the right hand side, and here y is eliminated to give you x equals to 2. So once you have x equals to 2, you substitute into whichever equation that you want. In my case, I chose 5x plus 3y equals to 13. So here, follow up the steps. I will have y equals to 1 as my final answer for this one. So this is how you do elimination method for simultaneous linear equation. Now, moving on to the second method of solving simultaneous equation, which is, we call it substitution method. So here, substitution method involves substituting the content of the subject of any equation that you see. For example, here, if x or y is the subject of one of the equation, we can always substitute the expression, whatever the content is on the right hand side, into the other equation. So here, for example, if you have 3x minus 2y equals to 6 for the first equation, and as for the second equation, you have a subject of y equals to 2x minus 5. So what you're going to do is substitute the expression 2x minus 5 into the first equation and effectively replacing the y in the first equation. So what happens here is that you can always take first, substitute equation number 2 into equation number 1. So what happens in that is that 3x minus 2y, the y part is replaced with 2x minus 5, while the rest of the terms remains the same. It's just that here you are replacing y with 2x minus 5. So what is the rest of the steps? The rest of the step, you are going to just continue with what you have and try to solve for this equation, which is 3x minus 2 bracket 2x minus 5 equal to 6. So what you can do first is to expand the 2 into the brackets, the content in the brackets. So you have a negative 4x, and then 2 times 5 is plus 10 equals to 6. So here 3x minus 4x is negative x plus 10 equals to 6. So here negative x is equal to, once you move the 10, so you'll have 6 minus 10, you will get a negative 4. So therefore the x equals to 4. Now the same thing happens here with the previous method. You also need to find y, but here to find y is very easy because in the second equation you have y as a subject already, so you just have to substitute x equals to 4 into the second equation and you can find y easily. So here substitute x equals to 4 into equation number 2. So you will have y equals to 2 times x is 2 times 4 minus 5. So this is 8 minus 5. So therefore y equals to 4. So this is how substitution method looks overall in this example. Right? Let's have a look first, and I'll give you a few seconds to have a look before I move on to the next example. Now, for the next example, in some cases, you need to change the subject of any equation before using the substitution method. So here, this is a very useful information. This information is used for the next subtopic, which is involving one linear equation and one nonlinear equation, in which the substitution method is very effective. So in this case, I will like you to do it yourself later after I explain the first step here. The first step here, let's have a look at the equation. X minus 4y equals to 3 for the first equation, and 3x minus 2y equals to 19 in the second equation. So here, what you can do is to make x the subject in the first equation. So basically here, an easy thing to do is to make sure that you can identify which term or in the both equation has one x, for example a coefficient of 1. So here in this case, you have found that x has 1 as the coefficient, so this is easy to make as a subject. So here what you can have is, for the first equation, you move the negative 4y into the right hand side, which will give you 3 plus 4y. So here, let's consider this as your third equation. Alright? Now, for the second equation here, you don't have to do any change, but just identify which one of the unknown has to be replaced. So in this case, I will rewrite the second equation, but I will focus on x. I change the color here, so you can see here x must be replaced with 3 plus 4y. So the statement that you can write down is substitute equation number 3, or you just can write down 3 into equation number 2. So what happens next is that in the second equation, the 3x is replaced by 3 bracket 3 plus 4y. Because it's an expression of 3 plus 4y, suggestion is to give brackets for 3 plus 4y, and the rest of them can be solved simply. So here, pause the video and try to solve for both y and x. Alright, if you properly solve for both y and x, you should be able to get y equals to 1 as your final answer for y, and as for x, you must get a 7. So just want to explain briefly what happens here. So please be careful in this part where you have to expand 3 into just the terms inside the bracket. So here, if you proceed, so here simplify what you have for the first equation, you will get 9 plus 10y equals to 19. So 10y equals to 10, which will give you y equals to 1. And when you substitute y equals to 1 into the third equation, because it's easy to get an x afterwards, so which means x equal to 3 plus 4y will be 3 plus 4 times 1, which will give you 3 plus 4. Therefore, your final answer, x equals to 7. So please keep in mind that for the next topic, substitution method is very important and you have to master it before you move on and proceed to the next chapter. And with that, to conclude for this subtopic, linear equations has two solutions that you can use, which is the elimination and substitution. So you are free to use any method that you like and you're comfortable with, but then elimination method is the one that is commonly used, although you can always use substitution to check whether you have the same answer. And also, since simultaneous equation has two solutions, x and y, you can always try to check by substituting the values of y and x, or x and y, into either of the equation. You may check it here, maybe the second equation, or in this example, maybe for the x equals to 2, y equals to 1 into the second equation. And if you have a match, that means you are doing the method and you found the solution correctly. So with that, see you next time in the next video. Thank you very much and goodbye.